I benefited from a liberal arts education more than anything, And it, of course, took hold as an undergraduate, but it started much earlier. Probably some of you will have the same experience. I invited my brothers and me to his laboratory up at St. Olaf College, a wonderful little campus up in southern Minnesota, very, very much like the Rhodes campus. It was selective, it was very demanding, it was very warm-hearted, it was all Norwegian. That's one difference. But we did little experiments. They weren't experiments at all, they were little demonstrations Dad had to read for us. When you're 6 or 7 years old, to take a drop of a colorless solution from one beaker and drop it in the other, it turns bright pink, because one is acid and one is unbuffered indicator. It's amazing. And when you can do things like that and understand it's not magic, it's something else. So science was early on something I really liked, but the literature also, from what I got at home. He assigned us one major task, to do a chemical experiment or demonstration. And it was required to pass the course. And like a lot of other young males, I kind of procrastinated. And about 2 nights before this was over, I said, Dad, could you think of something I could do at school that would be kind of cool and involve chemistry or something? He was waiting for this. So I have a great idea. So what's that? You could demonstrate the differential oxidation potentials of metals in water. I thought, what? Watch my nail rust? No, this is great. So he comes home from his lab and next to a little box and little beakers and test tubes with solvent and little slivers of metal. So there's no periodic table here. But on the far left column of the periodic table, up at the top it's hydrogen, and below that it's lithium, sodium, potassium, rubidium, cesium. And the atomic weights of these, of course, reflect their oxidative potential. So the idea is you take a little sliver of the lithium, you drop it in water, and it fizzes around. It's kind of cute, it kind of fizzes around, and the other kids thought that was fine. And so the next step was to take a sliver of sodium, which is kind of explosive, and you have to leave it away from water. It was in a solvent. It was probably in hexane. I never listened too close to some parts of this experiment. So I take the sliver of sodium on it, and I drop that on the top of a beaker of water. And that shoots around like a yellow flare. It's quite violent. Everybody's really interested. And so now comes the coup de grace potassium, which explodes pretty violently in a bright pink flare shooting around. All the kids were really amazed. Mr. Jensen's eyes were wide open. And what I didn't do is listen carefully to how do you take down the experiment, And what I discovered is it'll take itself down. So I dumped everything in the sink, and, potassium hit the water, ignited the hexane. The sweater my mother had knitted me for Christmas was singed, and my eyebrows were burned off. Then I had to repaint the ceiling of this class. I think deep down in every scientist, and there may be some other scientists too, there's always a blow up the lab story. And but I ended up enrolling in Augsburg College, a small liberal arts college at Dad College. He first was chairman of chemistry at St. Olaf, and then he went to Augsburg, which is a challenging school because they didn't have the resources, and most of the students had part-time jobs. First-generation college students that had an excellent faculty, and they were really stimulating and really learned a lot. And so I worked in the summers at the University of Minnesota in a laboratory. We were close by, like Rhodes is close to St. Jude, working in a lab and doing sort of rudimentary experiments in a surgical lab. And a very attractive young lady came up and said, I understand you're a medical student. I said, well, yes, I am. And she said, well, what do you want to do when you get out of medical school? I said, I'm studying diarrhea. And the liberal arts is something I've always carried along, and in the science as well, looking for practical applications, reasons to do work other than just to write reports. Phone rings, serious voice at the other end of the phone. This is an important phone call from Stockholm for Professor Peter Agre. Are you Professor Agre? Yeah. I said, I sure am. And of course I knew what this was. And they told me I'd share the Nobel Prize in Chemistry. But then I had a big pang of anxiety. Having nearly flunked high school chemistry, I thought, wait a minute. Should I share this with the Nobel Committee? Maybe better not. And I think the value of the liberal arts education is that you're not just unidimensional. You can go in many directions and bring things to people that might otherwise be too complicated. So I've made this a point of speaking to school groups, speaking to public citizens and trying to share the good news of what science can do, but in the context of general education. When I got the Nobel Prize in Chemistry, I better learn some chemistry. This is the extent of my chemistry. So if you listen closely, you might faintly hear the tune of the modern Major General from Pirates of Penzance. And it goes something like this. There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium. Europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and acidium, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, and terbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, chromium, lithium, beryllium, and barium. There's yttrium, and terbium, holmium, and helium, and hafnium, and erbium, and phosphorus, and francium, and fluorine, and terbium, and manganese, and mercury, molybdenum, and magnesium, dysprosium, and scandium, and cerium, and cesium. There's lead, praseodymium, and platinum, plutonium, palladium, promethium, potassium, polonium, and tantalum, technetium, titanium, tellurium. And, let's see, cadmium, and calcium, and chromium, and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium. Almost like Rhodes. Rhodium. Chlorine, carbon, copper, tungsten, tin, and sodium. These are the elements they know about at Harvard. But those who study chemistry at Rhodes in Memphis, Tennessee, will universally agree that others were discovered. The last part I just made up. But you know, it was sort of fun. Chemistry, science, is part of the liberal arts, it's part of the educational system. And I think Lara meant well in all of his songs, even National Brotherhood each song. On the other hand, the investment in the future is always something that has got to have special consideration. I mean, that's why I think our kids are here at Rhodes. This is an investment in our future. Carly, someday you're going to put me in a good nursing home.